So here's the story, to recap. Super Daniel, the mighty rower, rows straight to a dock that is to the west across the mighty river currents. He must choose to row in a specific direction to achieve goals such as this, and what we would like to do is find that direction. Find that direction.
Like find the direction he goes so he'll like drift into the...
Yeah, what direction must he point his boat in order to go directly west? So here, before we even do any math or draw any pictures, you tell me, how should he orient his boat if he wishes to actually achieve his goal of going west? Yes, ma'am?
Somewhere in between north and west.
Yeah, sort of up in the northwesterly sort of direction. Out that way, sort of, right?
Yeah.
We're not being specific here, but sort of out that direction. So, common sensibly, assuming there is such a thing, northwesterly, sort of, kind of. Okay? So I want to spell it out so that we have, again, a method by which we can do this systematically. Okay? So we would like to say, I want to find the velocity of the boat relative to the shore, or the direction at least that should happen in. Velocity of the boat relative to the shore equals velocity of the boat relative to the water plus the velocity of the water relative to the shore. Nothing's changed from before. Well, that rhymes. Velocity of the boat relative to the shore, or at least Super Daniel's dream, is to go, right? West. I'm drawing a little sketch underneath of my algebra. And the velocity of the boat relative to the water, you people tell me, sort of looks like that. Is that what we're assuming, according to some sense that maybe some insight you may have into this sort of situation? And according to the diagram, the river is flowing this way. But you know what? I wouldn't have even had to have any insights. In other words, I don't even need to have common sense about this, because if I'm looking for an unknown vector, see, I'm covering it up right now. If I'm looking for an unknown vector that adds with this vector here in order to get this vector here, there's no other option than one that looks like this. Can you see that? It's the only option. You don't even need common sense. You could be a buffoon that's never seen a river. Not that all people that haven't seen rivers are buffoons. But you could know nothing about this. Okay? And it would still be possible to solve it. All right, so here's how it goes. Velocity of this vector plus this vector adds up to this vector. I'm going to draw it as a picture. This vector, velocity of boat relative to water, plus this vector, velocity of the water relative to the shore, results in this vector. See, the resultant doesn't always have to be the hypotenuse. In this case, it's not at all the hypotenuse. It's the horizontal one. It's just the result of the other two adding together. Okay? Resultants aren't always the hypotenuse. In fact, in this very simple situation, it's not. Velocity of the boat relative to the shore is a westerly vector. And it's also the resultant. All right, so what we'd like to know is what direction, because that was the question, what direction must Daniel point himself in? That theta value there. Okay? So I know this value. I know this value. What do you want to use, SOHCAHTOA or TOA? TOA. We got the opposite and the adjacent, yeah. So if I want to know the direction in which Daniel must point himself in order to achieve his dreams and goals, tan theta is equal to opposite, VWS in this case. So we have to have some sense about this. VWS divided by VBS. So we get to say BS one more time. And we can calculate our theta value. Tan inverse of WS, that was 7 meters per second, divided by BW, 10.0 meters per second, and tan inverse of 7 over 10, I calculated to be 44.43 degrees. Okay, 44.43 degrees. Now that's approximately 44 degrees.
Wait, did you write VBS there? We don't have VBS.
VBS.
Can we go with
Oh, Hokey doodle. Hokey doodle. Well, it's a good thing that I made a silly mistake because now we can highlight how anybody can make mistakes and how I'm not as perfect as you might have thought. All right. Opposite over hypotenuse. Is that what we have?
Oh dear, I was copying all that.
We have opposite.
We have opposite and hypotenuse. So what do we use? Tan or sine or cos? Sine. Oh, man. Oh, man. Shattering your dreams.
I'm gonna wait for you to finish and then I'll.
Sine theta equals VW. Yeah, we sinned.
Awesome writing in pen.
VWS over VBS. Hey, I'm writing in pen too here.
White.
I'm not only writing in pen, but I'm also recording.
All my whiteouts.
Oh.
Well, that's why you fall behind in a note like me. Then you only have to erase one thing.
Theta equals sine inverse.
BS again. Isn't it?
Oh, it's
isn't it
BW. I'm so hung up on
Yeah,
BS.
cut it out and
WS. Thank you. 7.0 meters per second over 10.0 meters per second. Oh, well, the answer's still right, even if my writing was wrong.
time out.
Actually?
Yeah, it is.
Are we still trying to find
How's
that
it
bottom
still-
line though?
It's still right because I did this calculation earlier,
No,
and
but
I
even if it's sine or tan.
no, it's not. It's not tan. I messed up.
No, I mean like the answer if we did.
Okay, this whole thing is junk, and I copied the answer down off of my earlier solutions when I got this sort of sorted out. Yeah. Yeah. If it was tan, it would be an error. You plug it in. You're right. It has to be greater than 1. So type in sine inverse if you want to check my work. Sine inverse of 7 over 10. What do you get?
Can't trust a teacher anymore.
Yeah. You can't trust your teacher. Who can you trust? Yes.
Are we still trying to find the bottom line there? Or are we trying to find the hypotenuse?
We're just trying to find the angle because we want to
I know.
we want to tell Daniel where to go.
I know, but in the long run, I'm trying to find
That's all we're doing right now.
So sick.
We will find the yes. After this, we're going to find the hypotenuse. Oh no, we want to find that. We're going to find that guy.
I'm getting real frustrated.
That's what we're going to get. That's the gosh darn next step.
Thank you.
Okay,
What's the next step?
I'm not talking to you.
BS.
All right, 44 degrees though. 44 degrees. That's the direction we tell little Daniel, Super Daniel, to go in. We could say, Super Daniel, point yourself in a direction or on a heading of west 44 degrees. How's it going to end? North. Okay? And now the demand has been made in no uncertain terms. What's the next step? What would a part B for such a problem be? Is what I'm being asked?
I knew it was coming.
Well, it is coming. Pardon me? Can you... Anybody want to guess who asked?
Yeah.
Same offenders as usual. All right, B. Here's the B.
I'm a B.
What is Daniel's resultant velocity?
It sounds very.
Wow.
Well, you could say, at what velocity is he going to row west at relative to the shore? But that's the same thing as saying Daniel's resultant velocity in this case. What is Daniel's resultant velocity? Or we could say, what is Daniel's velocity, or his boat's velocity, relative to shore? Now we'll solve for BS, okay? Now we're getting down to the BS. And so we're still looking at the same diagram here. We know velocity of the boat relative to the water. We know the velocity of the water relative to the shore. And so I'm going to label up that same vector diagram again. I want to know the velocity of the boat relative to the shore. I know that the velocity of the boat relative to the water is 10 meters per second. And the velocity of the water relative to the shore is, we said it was 7 meters per second. And now this is another thing I don't want to mess up. A lot of people will say, oh, VBS squared is equal to 10 squared plus 7 squared, all square rooted. Right or wrong? Wrong. That's not the hypotenuse. Come on. Grow a brain, Einstein. Velocity of the boat relative to the water squared is equal to the velocity of the boat relative to the shore squared plus the velocity of the water relative to the shore squared. I know this one. I know this one. And I want to know this one. So I've got to isolate it before I sub in my values. So I would say the velocity of the boat, or VBS, is equal to the square root of velocity of the boat relative to the water squared minus the velocity of the water relative to the shore squared. I want to make sure people know where that minus sign came from. It's because I took the VWS squared over to the other side of that equal sign. It became negative. Negative VWS squared. And then I square root both sides. Okay, so I'm cutting out some steps, but these are steps that we should be able to follow. Yes, sir?
Why do you have to do the square root in the squares? Can't you just do VW minus VWS?
Well, you can try it. Try throwing in some random numbers. See if it comes out to the same answer. But Pythagorean theorem is a very sound and well-tested theorem. If you just throw in the numbers without having the squares there, you will never get the same answer. There's a few rare exceptions.
Doesn't the square root like take off?
No, not when you add them together. No.
Because you have to add them together.
Yeah, you have to add them together
Right.
first. Yeah, that's important. And you can do some experiments with that. I'm not going to do that as an aside today, but you can. Okay,
Your free time.
velocity, yeah, on your free time on a Saturday. It's okay. All right, VBW, 10 meters per second.
Wait. Time out again. Did you just move the BW into this?
Yeah, I took this WS over to the other side so that it was VBW squared minus VWS squared equals VBS squared, and then square rooted both sides. I skipped out a couple steps. Okay, so I just rearranged it a little bit. Yeah, it is going to be a long one. 7 meters per second. I just know this is a bit of a long note, so I'm trying to make some abbreviations. So if I leave people confused, please speak up like that. All right, so 10 squared is 100. I can do that in my head. 7 squared is 49. I can do that in my head. What's 100 minus 49? 51. Square root of 51 in my head. I usually use a calculator. What'd you get?
7 point something.
7 point something. 7.1 something, I think. 7.141. 141, and the meter squared per second squared gets square rooted as well to give me meters per second. Now it happens that this VBS, based on my calculations, is westerly. So, oh no it's not. What am I talking about? Is it westerly? Yeah, it's westerly. VBS is westerly. Yeah, VBS is westerly. All right, let's break up this video and make a new one.